Okay, I am recording. This is my little tech talk. I'm sorry for the music. If it's annoying, you can mute it. It's calming me down. So we're gonna do a deep dive into unit testing with TypeScript, and I'm gonna teach you about mocking. And this is aimed at someone who has never ever done testing before, because I'm going through like very basic explanations. Also, side note, if you did take the testing class in SON, I don't remember the class code, you do touch on unit testing. I don't think you do any mocking, maybe a little bit, but they don't really explain it. And I remember doing it and I was a little bit, I guess, disappointed in how it was being taught. But anyways, so a little bit about me. I'm the one that made the ENCS Discord, for those that don't know, but I think everyone in the chat would know. I have a chemical engineering degree from McGill that I finished, and I am currently in my last semester in software engineering, and I'm graduating at the end of this. My experience, I had 2 internships at Autodesk. I worked with Node.js, and I was part of the infrastructure team. What I did for Autodesk was that I made scripts originally. So when I came in, I was a first year. I had done, I think, the first 2 Java classes, and I got hired, and my manager wanted me to basically learn the basics. So he's like, okay, you're gonna write scripts just to like get used to Node.js. And because we're working in a DevOps environment, you have to do your own tests, and you have to make sure that your piece of code runs from the beginning to the end of its life cycle, meaning once it goes to production, to the app, to whatever end goal you have to make sure that it works at every step of the way. No one else fixes your code or makes tests for you. You have to maintain it yourself. After that, they made me add metrics to their backend code, and also I added server scaling, a server scaling module. It wasn't really backend code, but it was to help the backend code that they had, which was to manage a server. So it's not really backend, but you still end up doing like similar coding. So I did tests for everything that I had to write, and most of it was unit testing and a little bit of integration testing, which I'll explain in a little bit. What an infrastructure team is that they're responsible for making the lives of actual backend developers easier. So you do a lot of scripts. Maybe they want to manage the way they manage their modules, or any task that's very repetitive. Maybe there's a way for us to automate it so that they don't have to spend time doing that, so they can just code faster. That's basically an infrastructure team. And a lot of it is also maybe making repositories. Like, they want a new repository, so they have someone from infrastructure set it up so they don't have to waste time doing it. All of that like nitty-gritty stuff in the back. And I just mentioned I did DevOps with them, but they also had the mentality of test-driven development, which is an agile method, which isn't really implemented in industry. We didn't implement it that well either, but basically it means that before you write a piece of code, you actually write the test for that piece of code, and then you build your test as you're building your code. I'll talk about how you can do that in the example. I actually did do test-driven development a little bit when I did my example, so I'll take you through it, but it's not a necessary development technique, but it does help you write better code. It just takes more time. So what is testing code? When you guys write code in your first year, they don't really tell you how you can test your code. They just tell you to do console logs, essentially. Like you said, Ariel, I can see the chat. Or you do, system println in Java, for those who haven't seen any other language yet. And you put your own inputs in your function, and then maybe you print out like stuff everywhere to see if it behaves correctly, but you're not checking every possible pathway, because you don't know exactly what can go wrong. You're not used to the code, which is perfectly fine. You just want to see that you're printing the right stuff, probably. Well, I'm here to tell you that in the industry, there's ways to automatically test your code. So instead of writing anything in a terminal you want to run your file, you don't even have to actually run your file. You can run it through a test suite, and the test suite itself will run pieces of your code or your entire code base if you want against some conditions that you want to test to make sure that it works. So a unit testing is a form of automated testing. And I put here in the bubble a lot of words, a lot of lingo, part of the testing world. I am not familiar with every possible testing technique. I like unit testing because I've done it so often. The second best for me was integration testing because it's another easy form of testing, but everything else has their own tools, and every company uses different tools. Different ways of testing, but most popular ones would be unit testing and integration testing, especially for backend code. Okay. So what is unit testing? Unit testing is testing code in very small units, and usually those units will be individual functions, but they can be bigger units of your code depending on how it is written. I've only ever seen people test individual functions, and today we will also test just individual functions. And the goal of unit testing is to make sure that that little unit you have behaves exactly the way you expect it to behave, given the assumptions you have written it in. And the advantages of unit testing, the first one would be that it facilitates safe refactoring. What you're going to notice in unit testing is usually you wrote your tests and you want to change something in your code, but your tests will start to fail. So you will know if you refactored something wrong or if you need to refactor your testing as well. A lot of the times you usually need to very minimally refactor your testing, but you will know that your backend code was badly refactored if you need to do too much maintenance. And because you write so many unit tests and you're testing very small units, you actually end up finding bugs in really complex code because you're breaking it up a lot. So you find a lot of the defects really early on, and it actually reduces costs for your company because you no longer have to waste time finding a bug in the future that is in such a weird place that you couldn't have thought about in the beginning. It also improves your code quality because when you write with test-driven development methods, you think about your test while you're writing your code. So you don't want to have a really complicated function that tests a million pathways because your test is going to be insane. It's going to be annoying to write so many conditions for a test. So what you end up doing is you make little functions that you can test very easily. So it ends up making you decouple your code, I believe is the right word. And because you write unit tests and you find code defects early on, you can then go to a more complicated testing framework like integration testing, and you won't need to do super heavy testing because you'll have less bugs to take care of. Do you understand? It makes other testing methods easier. It also simplifies debugging. So one of my favorite things about unit testing is I no longer need to open up every resource to see if my program runs, unless I'm checking for an end product type of thing. But if I just want to debug a couple of files that I'm working on, I just need to write a unit test and start the unit test in debug mode, and then I can go through my code instead of going into my console or my terminal and running my code and then checking through console logs everywhere, or even just running my code. If you look at IntelliJ, you'd have to write a main file that calls your module with whatever you want, and then you can see the debug through it. But if you do unit testing, you can write a unit test for each function, not your entire module. So you can split your debugging process at only for that little function, and its flow after. So that's one of my favorite parts. And it also improves the design of your code if you write with unit tests in mind. Now, there are disadvantages, and a lot of people dislike unit testing, and why they dislike unit testing is because it kind of increases the amount of code you have to write. You essentially end up writing, I think, almost the same amount of code, so you kind of duplicate your code. That's not a real statistic, but for me, what I notice is my unit tests are almost as long as my actual function, and on top of that, I have to test multiple pathways, so I end up repeating some code, but that can be, of course, managed by a proper organization of your variables. It's really good for business logic, so like server code, backend code, anything like that, but everything that uses UI is really hard to unit test and maybe not unit testable at all. It is not useful. And unit testing is good if you test the right conditions, because if you start testing something that doesn't really belong, you kind of mess up what you're actually testing, and your test results will mean nothing. So if you're not testing the right behavior of your code, your test results will mean nothing, even though they are positive. If you have a bad test, it will be useless to other people, maybe to you, but to other people it will be useless. And a lot of the things that you have to do in like your last years from SOAN is they force you to have like a high coverage. So they teach you like, okay, you have to do testing when you do your capstone and SOAN 341, or I think it's 341 and 343, I don't remember, but all of those like design classes, you need to have tests, and they always say like, oh, what's your coverage? You get a grade on how high your coverage is. And I kind of get annoyed by that, because we get into this world and we don't really know how to test properly, and no one really teaches us. They kind of like give you a very quick example of each type of testing, and then you're thrown into it by yourself, and then they tell you that you need to have high coverage. By the way, for those who don't know what coverage is it's a tool that analyzes if you've tested every part of your code by running your unit tests or your testing framework. So if you never go through a line of your code, that means you have not covered that line. So it's not part of your coverage, and you have a lower coverage. Now, to achieve a high coverage, you can totally cheat in unit tests and just make dumb tests that have dumb conditions that mean nothing, but just because they go through that line, you get high coverage. So I just don't like the fact that they force high coverage versus teaching how to write better tests, but that's like my own little pet peeve. And of course, another disadvantage is you cannot test every possible outcome, because code is complicated, and you want to focus on the most useful outcomes and not waste too much time testing outcomes that are not so probable, or that could be caught with other tests. So I think I've said it already, like why I think unit testing is important. It was my favorite way of debugging. That was one of the first ones, but it also originally really helped me understand my code, because when you start writing a unit test, you start thinking about, how can this go wrong? How can I break my own code, and what happens if I break it? Is it behaving the way that I want it to if it breaks in that way? And then you also increase your analytical skills, because then you look at your piece of code and you ask yourself exactly like, how can you break it, but also what assumptions did I make when I wrote this piece of code, and are those assumptions always going to be valid? And also, let me break those assumptions and see how my code behaves, and does it do what it has to do? Now, of course, you can go in this loop forever, and it can lead you to a useless place, like I said, so it's a compromise that you have to make with yourself. But it does help write better code, because you constantly think about, okay, how does this look when my assumptions are broken? Or did I think of every assumption possible? And that's how you end up finding a lot of bugs. So what are we going to test today? I wrote a really dummy DynamoDB singleton with a wrapper around it and two functions that add a user to a database and remove or get an item from a user base. Sorry, not remove. This is what we're doing in my capstone. So I just kind of took some functionality that I had in my capstone functions, and we're also using TypeScript, which is a programming language for those who don't know. Mocha, which is a testing library, Chai, which is an assertion library, and sinonJs, which is a mocking library. Now, before I go into more details, what is mocking? So up until now, I've talked about unit tests and how we're testing like super small units of code. But those small units of code generally probably call a resource or an external module that you need to have it connected to your computer. So whether it is DynamoDB that I have connected on my local instance on Docker, or if it's online through their own servers, whatever it is, I cannot possibly test my code in completion if I don't have that online. If I were to use, for example, a command line or a terminal or whatever, I would have to probably have that resource online to see if my code works. And then I would have to not only have it online, but I'd also have to go check inside the database if I added that user correctly. Now, I'm here to tell you that mocking is a way to completely avoid online behavior, and you decide whether those functions from DynamoDB accept or reject your inputs. And then basically you replace complex objects with fake objects. So you eliminate the need for being online, essentially, and you simulate behavior of that module. I'm using sinonJs for my library in this example. There are many out there. For me, Sinon was the most intuitive one, and I'm used to it. It is a proxy-based mocking framework. I'm not too familiar with what proxy-based or the other methods are. So if you're interested, I invite you to Google it. I probably cannot explain it as well as they can. But basically, we're using mocking because we don't want to test external code. We just want to test our little unit and whatever happens to it. And that unit happens to depend on DynamoDB in our example. Like I said, Mocha is a unit testing library. It helps have this dialogue of how the test will work. And Chai is an assertion library, which inserts some type of grammar that makes how you write your tests kind of read like the English language, and I'll explain how in a sec. Most libraries have the same kind of workflow. It's just maybe the grammar is a little bit different, but essentially they're all kind of made so that when you write a test, you can almost understand in plain English what you're writing and testing. And I'm gonna show you a test in general, how it looks like. It's the same as regular code, but because we're adding those libraries, we're gonna add some magic. Each test case will test one condition pathway. So for example, I want to test that my user was added to the database, and it is a good user variable, and I would write it if I was testing say only the user variable, I'd write a describe function that would have a general description. So this is kind of the title of your testing file. In this case, you can have multiple describes depending on if you want to separate the formatting of your test. This is useful because at the end, when you run your test suite, you print out your summary of your test, and everything that shows up in this little describe string ends up being printed to your console. And your here, the second function, which is inside a describe, is a test case. So this is one test case, meaning it tests only one condition. If you test multiple conditions, you are in a pitfall, and it's not a good practice because you're no longer testing one behavior, you're testing multiple behaviors. So for example, I just want to test if my user, which is a good user, is added to a database when I do one function. Yes or no. If it is yes, my test passes. Great. I use the term assert, which is from the Chai library, to say that I am asserting that this condition is true. This function, if this condition is false, will fail, and the test will fail. And it will only be this test in this little it over here. Should behave like X, will fail. I will show you examples. I'm just gonna take a breath and breathe for a sec because I'm drying up. Are there any questions so far? Because I'm going to go into an example. Okay, so let's get started. So what I did is I went and I got my little dynamo over here from AWS. I wrote a singleton class. I'm using a local instance, although anything over here technically doesn't really make a difference in unit testing world, because this never actually completely runs It can be defined in any way and it will still work because I'm kind of mocking Dynamo in the end, you'll see. But for the sake of having a real world example, you usually have a singleton class and then you get an instance of your Dynamo and then you wrap the methods that you want, and I'll show you in the next slide. I made a user model over here, and this is my main variable that I'm sending to my database and retrieving. This is my file structure of my source file. This is my database wrapper. So I hope everyone can see and it's not too blurry. If it is, I will go in my VS Code and show it to you from there. But if no one complains, I'm going to keep going. So what a wrapper is essentially is something that has the database instance in its own private variable, and you're just calling that function for Dynamo, but you're using your own wrapper. It's I'm not really sure how to explain it, but it's a design pattern, I guess, that is pretty popular. If there's a better one, please use that one. I was just familiar with this one in particular, and this is what we end up doing in our capstone, I believe. Actually, I don't believe I know we're doing this. And I wrote a runner class, which is a very basic kind of like a main class, if you will, if you come from Java. And I'm only using this to demonstrate two functions. My runner doesn't actually run anything, although I will call it to be able to call these methods that I'm going to show you on the next slide what they are. And this is just a main entry point for my application. I have an add user method over here, which takes a user parameter that I created, fills in empty data if I have no definitions for those datas, and then I create my variable that I'm trying to send to my database. So now I know from the docs that DynamoDB must accept this type of variable in order to like be happy with what it's receiving. So I need to put it in this format before I send it to the variable to Dynamo. And I'm sending it to my wrapper, not to Dynamo itself. I am not instantiating Dynamo over here. I'm instantiating my wrapper, and I'm sending that over. It's gonna take it over here to my wrapper, and then this wrapper calls the DynamoDB, and then my singleton class actually does something. So similarly, my get user does the exact same thing, except there is no data that I have to arrange. I'm just arranging the DynamoDB variable that I'm expecting. And once I get some data, I am making sure that I have received an actual item and that item is not empty, and that I do have a real user variable that I can extract from the data. So this is like super basic. In its format right now, it doesn't really do much, but it is just going to be used for testing purposes. The first thing I'm going to do is in my folder structure, I'm going to make a new folder called tests. Now, I don't know if Java is the same, but I think you take out your tests out of SRC and you make another structure, but I know for Node and TypeScript, it is kind of preferred that you have another folder with all your tests. And usually you want to have the same file structure. So if you're going to test your app.ts file, it's nice for you to name the test the same way, except you're going to have a .test.ts, which helps the test suite recognize which files are tested and whatnot. So let's write our first test as if I had not really as if I had not really said what as if I had not written these functions out first, but I would have known that I'm accepting a user and I am getting a response from the database. So I know here that I'm adding a user, which I'm going to put an empty object because I haven't defined anything yet. And I know that I'm getting an output from the database. And I'm asserting that at least I have an output just for the sake of this test. This means assert my output exists, assert there is an output. And I'm going to do the same thing with my add user again, but I'm going to assert that it does not work. So first, I want to add a user to the database. That is the condition I'm testing, that the user was in fact added to the database. And my second condition on the same function, I'm testing that the user was not added to the database. Because you can also test failure. You can force failures. So let's start with this and let's run it. What we can technically, oh yeah, I said to account for the empty object over here. So does anyone know why this would fail? I mean, I wrote the answer, but like, does anyone know why if I run this, even though I wrote my piece of code the way that I have it, and my fake, like my just quickly made up test would fail? So in this case, they would fail because I don't have an actual online resource. I have not actually opened my DynamoDB. There's nothing running. I am only calling my app as it is. And it's actually going to stall because it's going to look for the resource. And I don't know if you're familiar with async tests or async in general. It's calling for a promise or a callback, and it's waiting for that callback. And it's like, okay, database, add this user, add this user, add this user. And there's a time limit in the Dynamo code that goes like, okay, it's been like 30 seconds. I haven't found like the Dynamo instance anywhere on your computer, and I can't do anything, so I'm going to return an error. But my tests actually end up running, but they time out. So I'm not even getting an actual a real error from the database. They time out. So this is really, really not helpful in industry because you don't actually know why your tests fail. But from experience, I know that it's because I haven't taken care of my Dynamo resource. So my tests fail, and then my code actually runs and finishes very, very late because, like I said, it's still looking for that resource. Okay, so the error that we actually got was over here. We could not add a user to the database, which I am catching that error when something goes wrong with my wrapper functions, which in turn returns an error from the Dynamo function, which is called through here. So I'm rejecting it here. I have put these console.logs in comments because I don't want to double the error log, but usually I have my logs over here, I think. Because the reason why you have a wrapper, you can also kind of edit the errors that you send throughout your code. Because, you know, Dynamo will return like a super cryptic error, and maybe you want to put it in like a language that you want to understand. So a lot of the times you want to catch and rethrow just to like change the error name to make it more readable. Or maybe you also want to do something, because I think it also returns an error if it cannot find an object. Oh, and by the way, my database is not even connected, and I am not getting an econ refuse error over here. So like, it's a mess. So you want to deal with that maybe in industry. Like, if you're not connected, how are you handling your code? Like in this test, you can see it's like really not helpful, and my code is not behaving in a very useful way. If this error were to happen in industry, you wouldn't know what the hell happened. You just know like, oh, there's a huge timeout and it couldn't add the user to the database. Okay, but why? You know, maybe you want to catch that specific error and do something with it and like print something or like stop something or whatnot. So this is why it helps you really think like, okay, what am I doing with my code? I see free coding practice. Okay, that maybe is not meant for me. So let's start adding some mocks. Now, a little bit more introduction of testing, I guess, lingo. Before each function, we'll run anything inside this function before each test case. So my test case are these it functions over here. I have 2 of them for now. And I am saying that I want to get the Dynamo variable instantiated because I'm going to mock one of its function. And this is a sinon lingo where I'm creating a sandbox, and I'm going to use this variable to create mocks or stubs in this case. And when I'm finished with it, I can restore anything that I faked. Because if I leave any sandbox, stub, mock, spy, or whatnot, if I leave it hanging without restoring it at the end of my test, I create this proxy that will kind of linger in my code and can mess things up over time. So it's always good to always restore whatever mock and stub that you create. So same, it's an after each function will run after each test. So every time I'm running one of my tests, I will go here, I will create something, and then I will go through the test, and I will go in the after each. So this is going to get a little bit ugly purely because AWS has really ugly inputs and outputs. I am sorry, but please bear with me. So if I want to add a user to my database, I need to have an item output that I am expecting from my database. So if it works from the docs in AWS, I know that my output needs to look like this. My table name just happens to be user, but obviously you can change it to whatever you want as long as you're consistent. But what you need to know is like, okay, so I know that when my put item dynamo function succeeds, it will give me this thing. Now, another really weird thing about Dynamo is that it handles promises in a very cryptic way. So I have to have this like weird wrapped promise function, but it's essentially the same thing as returning this. It's just I have to wrap it in this promise because of some ugly code that they have to make it work with promises. Now, if you're not familiar with promises, I am sorry. It is asynchronous code. I cannot explain it. It is out of the scope of this tech talk, but try to understand, I guess. So the stub that I'm going to be doing is going to go and I'm going to call sandbox, which is my sinon variable that helps me make stubs. It's just called a sandbox because you think about kind of like kids playing in a sandbox and you have like a lot of little things that you can mess around with. So it's like your own little, I guess, sandbox. I don't know how to explain it, but anyways, I feel like gamers would understand what that means. So you stub your dynamo put item function. So you call your object and the function that you want to stub in quotes, and you say that that function returns my output that I am expecting. And I'm going to say again, return my runner, which is my original main code, my add user function, which is the one that I made, on an empty user object for the sake of the example for now. And then I'm expecting this output to exist. This is not a correct test right now. I'm just like implementing it slowly to make you guys understand how you can implement a test. So if I run this, it still fails. I skipped the other test I was writing just for the sake because I wanted to only test one thing. And it says that I have an assertion error. So I'm expecting undefined to exist. It means that I don't have an output. Yeah, maybe originally the way that I wrote my code, maybe I didn't actually return anything. But basically, this step over here fails. So I have to go investigate and see why it fails. We're actually not testing the right condition. So now I want to maybe add two tests, like something that makes sense. So I want to change it up a bit, and I want to test my output for the proper output that I'm expecting. So I'm going to call my add user function with a user parameter in this case instead of an empty object, because I want to test something that makes sense. If I test an empty object, I am not really testing something realistic. So let's add an actual user object. And I know that, put item. Okay, so what I ended up doing is to make my stub behave more properly, I said that when my dynamo put item function gets called with these parameters, it has to return this return that I am expecting. And then my function add user, I am checking that it returns the exact same thing that I told it to return. Now, because this is a super simplified test, it kind of looks like my test is useless, and I will admit that it's not the best test just because I don't have that much stuff to actually show for. But what I usually would do is I would go and I would end up spying on, say, my wrapper, kind of like this guy. I'd put a spy on it and I would check, okay, what parameters are you getting right now, and are they the same parameters as my input parameters that I'm expecting. But it's still like kind of a redundant thing, and the problem becomes when, sorry, I'm just trying to show you guys when here, so like this is the same parameter that I'm sending to my database. So this one I can just copy paste in my test and check that it's the same thing. But I can also check that every function has received this parameter. Because say, for example, that I want to go into my wrapper and change some functionality. That wrapper might break and my test will break. But I'll know why my test broke. So I hope it's clear. No one has any questions? Questions, comments? Okay, so we were here. And yeah, so I'm not testing for much here simply because my code is very, very small. But what I could do is return a more useful element, and I could return something that isn't the database response. In this case, I return the database response. So I know that the flow of my code, which is my base code, goes to my wrapper, goes to the Dynamo, goes to actually AWS. AWS says, okay, come back to Dynamo, come back to my wrapper, come back to my original code. So it does follow like 4 functions in the background, but I'm still checking for something that I'm expecting. So it does make sense. It's just not like the I guess it's just, it doesn't look obvious to you. So any comments? We can go to the next test, which is failing the function that I created. How I failed the function. So I created a AWS error object, and luckily for us, AWS must satisfy these ridiculous 10 item error names. And I'm, instead of resolving with a proper output, I am now rejecting with this error. So I'm mimicking the DynamoDB function. So essentially, like, I go into my docs, my AWS docs, and I check what happens when that put item function works. What does it output? What are the parameters that I need to fill? And then I also check when it fails, what does it look like? And actually, what helps me realize if I get all of these right is by having a local instance and running the test without having mocked any behavior, and just checking like through my debugger what was the outputted error and how does it look like. Otherwise this won't work. So you really have to know how to mimic that resource that you're testing in the background. So I'm having the same user. There's nothing wrong with this user, but I'm just telling the database function that you're gonna refuse. So Dynamo, I'm telling it you're gonna have to reject with this error over here. And now I'm gonna check when I run my add user with this user, I'm making it fail, but if it succeeds, it should go in this section. So I'm telling my test, assert that you're failing because you should fail this user. So we should never be here. So in your test, if you're testing for failing behavior, but your function succeeds, then you get to this line, your test will fail because of this line, because it shouldn't succeed in like, this function shouldn't succeed, not the test itself. But in the error, if you catch the error, you can check that your error is the error that you expected. So another thing you can do with like errors and whatnot is you can test for different errors. So some of them, sometimes maybe you want to test for, like I said, missing item, or it doesn't return anything. Is it going to throw an error in your code? If it throws that error, do you want your code to reject a promise? Or do you want to catch that rejection and make it resolve because it doesn't actually break your code? You know, it helps you go through the flow properly. So now if we run this, both of our tests pass. Now we're gonna go to our second function, which is the get user function. And the behavior is almost the same. You have a user variable, you have input variables and output variables that you're expecting. And of course you're making the AWS Dynamo function resolve because it has that little weird promise wrapper that you have to make. And you're telling your sandbox, okay, I want to stub my Dynamo get item with these arguments that I have over here. So if you get a function called getItem in Dynamo that receive these arguments, then I want you to return exactly this, which ends up being like my getItem, this one. So I do my getUser. I check, I do user.name or empty string. So this little like thing that I wrote over here is a TypeScript problem. Dang, JS Chad. No, you. This is a TypeScript annoying problem. So like when I declare my user variable with optional here parameter, it sometimes accepts undefined, and this function does not accept undefined, so it complains. So I added an empty string over here just for the sake of the test. Don't hate me. And then so I call my database. I'm like, okay, get me a user with this name, and when you're done, assert that my response does match my actual variable that I had sent that exists. So this variable I created myself. It doesn't actually exist in the database, but I am telling my mocked value that if you get called with these arguments, I want you to return this guy. So now if we remember, I think, am I sharing my screen? I'm not. Let's to go back over here, because it's a little bit important. If you remember, this is my getUser function in my backend. So I'm checking that my database did return some data that had an item variable. So why this is important is because all of the database from all of the Dynamo returns need to have an item variable inside the data variable. And inside that item variable, you'll have the user parameters as were defined, which is like this ugly thing. And I need to convert that into my user variable. So I need to do some logic over here. Now this logic can be tested, right? I can force this data to not exist. I can force this item to not exist. I can assume that this passes, but there's nothing. But I want to check, is my code behaving how I'm expecting it to behave if there is no data? Does it crash? Do I want it to crash? Do I maybe want to throw an error if there's no item over here? You know what I'm saying? Like, you can choose what happens because you're starting to think about like your mistakes. Okay, so we're over here. So I successfully get a user from the database, and this was with the item existing in that Dynamo return function. Now I'm doing the same thing, but with the error. So it's almost exactly the same pattern as like my second test, except I'm forcing an error and I'm checking if I try to get a user, it doesn't work, but the error is the same. So I don't want it to work, so I'm asserting a failure if it does end up working. But then if I catch an error, I'm asserting that the error is correct, so that my test will pass if I get to here and the errors are fine. So now let's try to test the pathway where there is no item in my return. So I'm putting my getItem output over here. This is my get, and I'm saying that there's no user, so there's no item return. I'm putting that, I'm removing the item variable that I was checking for when I was creating my user variable, and I'm expecting it to return an error, and it does. I think that's my last slide. It is my last slide. So I'll explain that one in more detail. So what I end up doing is I force this item to not exist. So if I weren't to have this if statement over here, I would have a behavior that would be a little bit weird. So I'm checking that if there's an item, make a user variable and return a resolved promise. And if there is not, I want to reject with this new error that I created over here. So actually, what I end up doing is I am rejecting with that error, and I'm checking the error message instead of creating an error variable, because I don't really need to. I don't have an AWS variable with like crazy variables to keep track of. So that's a very basic example. I really would prefer questions right now because I'm kind of done. Anybody?
Thank you.
Was it helpful?
Yeah, it showed a lot on how things work in the background. I mean, I'm a bit familiar with that code for
Yeah.
certain reasons, you know.
Yeah, yeah. It's very similar to your
But
capstone code, but like obviously not
yeah,
exactly. Um, it's a bit more simplified.
but it was nice. Like it helped me see the process of like getting started.
Yeah. Do we have one describe per class? So the describes are open to interpretation. You can have, usually you have one describe per file, and you describe what that testing file does. And you can also split it up into multiple sections. You can think of describe like a heading, where like your first describe is your biggest title of like the file, and then you can have a second one if you want to have a more in-depth describable. So like in this case, I have, this is my first heading. This is my console log, so they're a little bit embedded, and this is the it, how the it shows up. So the it is always a different color, but your describes are just like headings for your own like readability. And it's good practice to have very descriptive titles, so you can have many of them if it helps you understand your code better. Yes. Anyone else? Will you talk about writing tests first, then code? That seemed funky. Okay, I don't really do that either because it's a little bit hard. But what I do end up doing is when I'm starting to write a function, I'll just call that function with some fake variable, and I'll expect like an output. This is the promise like format where you call something, you check dot done, what happens to the output. And I'm only using this to debug. So I'll write this first, and then I'll write my function, and then I'll start filling my function in, and then I'll be like, okay, what happens when I have like the expected behavior? If I have a good user variable, am I outputting properly? Did I check for everything? And then you start thinking, okay, what if I'm missing one of the variables for my username, my user variable? Am I gonna return an error? I'm not sure, because you can't always think about these errors. So like it's good to start, I guess, writing the test early enough for you to catch that testing behavior. Because if you write your function entirely and you start running tests, you'll kind of realize that you made mistakes along the way. Oh shit, Alfie, Alfie. Hi. Let me know if I explained it well. Okay. Very funny. Okay, I'm gonna stop the recording for now.